If you work anywhere in the innovation pipeline and product design engineering, you've almost certainly seen this happen. A team finds a brilliant new way to use an AI tool, you get this stunning local win, right? Maybe a prototype or an amazing research summary. Everyone's high-fiving, and then the whole thing just dies.
Yeah.
Right at the handoff.
It's the classic information black hole. I mean, that brilliant prototype that exists in a tool silo, that deep research insight is, buried in some PDF somewhere. And when it needs to be integrated into the actual building process, you get this inevitable requirements drift.
Yeah, sure.
You start duplicating effort. And crucially, your path to scaling that local AI win.
Yeah.
It just stalls completely.
Stalling is the perfect word for it. It's the operational friction that kills velocity, not the tech itself. Okay, let's unpack this, because the sources we're diving into today, they present a real solution, one that moves beyond just, hoping teams talk to each other. They detail a systemic shift away from just celebrating those isolated AI wins toward, core system-level workflows.
And the mechanism here, it's brilliant in its simplicity and its rigor. It involves consolidating discovery, design, and delivery onto shared visual canvases, and then enforcing the use of standard artifacts, think mandatory templates, and embedding AI tools like Miro AI Sidekicks directly into the team rituals themselves.
So our mission for this deep dive is to explore that specific operational blueprint. It's called the product acceleration space. We're going to look at the specific structures, the mandatory templates, and I think most importantly, the hard metrics. The numbers that let you prove that alignment isn't just a feeling, but a quantifiable speed boost.
Yeah, we're essentially exploring a single, highly governed operating model. It's designed to create a measurable, repeatable loop where context is never lost and where AI acts as a continuous quality assurance layer rather than just a, one-off drafting assistant.
Let's start with that central idea then. The single visual operating surface, the sources call it the product acceleration space. And they say it's a named, branded space. I love that it's branded. It makes it feel important,
It does.
And this isn't just one giant, overwhelming board. It's organized into 4 linked, discrete segments, all designed to guide the team through the product lifecycle.
The structure is absolutely key because it enforces sequential behavior. For so many product teams, the temptation is to jump straight to designing a solution.
That's frame 2.
Or even writing the specification frame 3 based on an exciting idea. By physically separating the 4 steps, discovery, prototypes, spec, and delivery, it creates a kind of audit trail. If you start a spec, the system basically demands that you link the evidence from the discovery frame.
It sounds like the system forces you to slow down just long enough to ensure you're moving in the right direction. And then it accelerates you. Let's run through those 4 components, starting with the foundation, the discovery map.
Right. So the discovery map is where you take that messy pile of raw customer research, interview transcripts, analytics data, support tickets, and you forge it into something actionable. Its core purpose is converting observation into defined problem statements and high-confidence opportunity areas.
And what are the mandatory pieces of evidence that have to live there?
The core artifacts are very strictly defined. You need a research digest, clearly articulated problem statements, often using the jobs to be done framework, user journey maps, and crucially, opportunity sizing. These aren't just sticky notes. They're high-stakes documents that validate the whole effort.
And this is where that AI sidekick first really proves its power. Moving research synthesis past the point of being this manual, weeks-long effort.
Absolutely.
Yeah.
I mean, think about the manual effort of synthesizing 6 hours of interviews. Instead, you can use these specific tailored prompts. Summarize these 6 interviews into 5 core insights and 3 high-priority risks.
Oh, that's powerful.
Or extract jobs to be done statements from these notes and cluster them by theme. The AI does the heavy lifting of clustering and summarizing, so the researcher can focus on validation and interpretation.
But the sources are really strict on governance here, right? It's not enough to just put the summary up.
That's the non-negotiable part. For that synthesis to be trusted and actionable, every artifact has to pass the governance check. This means including source tags. Is it internal analytics, customer feedback, market data? You need the date, because research decays, and you need the researcher owner for accountability. That transparency is what gives you the confidence to move to the next phase.
Okay, so that quality control discovery feeds right into step 2, lo-fi prototypes. This is where you quickly align on direction using simple click-through flows, wireframes, sketches.
And this leads to the critical handoff rule, the one the sources say is the ultimate organizational speed bump. No specifications are written until at least one customer problem is evidenced and explicitly linked on the discovery map.
I have to challenge that a little. Isn't forcing product managers to wait until the evidence is linked, I don't know, overly bureaucratic? If I know the solution, why wait?
Because the whole system is designed to combat those organizational shortcuts that lead to waste. If you're a PM, the most common anti-pattern is jumping straight to a high-fidelity Figma design or a dense spec doc because you're solution-oriented. This rule ensures you never invest significant effort design engineering cycles in a solution that's searching for a problem. Lo-fi means low investment, high alignment. We're just checking the directional fit here, not perfecting the visuals.
That makes a lot of sense. It's an organizational friction mechanism, but a good one, designed to enforce prudence. Which brings us to part 3, the spec workspace. This is the heart of alignment, where requirements drift usually begins, and where the system really tries to lock everything down.
Exactly. This is where you write clear, testable specifications explicitly linked back to that validated discovery work and the approved prototypes. If the prototypes define the what, the spec workspace defines the how, and crucially, the why.
Let's run through the mandatory template fields, because this template is what guarantees that traceability and quality. You've got the epic or feature name, of course, but the necessary fields are what lock in the process.
They absolutely mandate traceability. You have to include the problem field, which forces a live link back to the specific insights and evidence on the discovery map. You got to define the outcome and metrics. This isn't a nice to have, it's what defines success. If this feature ships, what must actually move?
Right.
Then you detail user stories in the giving when-then format, list all constraints, risks, and assumptions, and any open questions.
We've all been in that engineering meeting where the acceptance criteria are vague and it leads to endless rework. This seems to eliminate that.
That's the final piece, and it's essential for engineering and QA. The acceptance criteria, or ACs, they have to be testable and numbered, and the AI Sidekick is integrated right into this drafting process. It acts as an instant editor, a QA pre-filter. Use prompts like, convert these user stories into acceptance criteria that are numbered and testable, or identify missing edge cases from this flow based on the listed constraints. The AI is ensuring rigor before a human even reviews it.
So we've found the problem, designed a lo-fi solution, written a rigorous traceable spec. Now for the crucial handoff, the final component, the delivery board.
Right. The delivery board makes handoffs explicit and measurable. It's not just a place for JIRA tickets, it's a living contract between product, design, and engineering. It uses specific swim lanes to track progress. Ready for tech review in, build in test and review, ready to ship, shipped.
What makes this better than, say, a standard Scrum or Kanban board?
It's the required linked artifacts at each stage. When an item moves to ready for tech review, it must have a linked spec, a linked Figma file, a dependency list. The swim lanes give you instant visual feedback on bottlenecks. If the in-review column is always packed, the system is telling you immediately that the bottleneck is peer review capacity or process.
And the Sidekick helps here too, doesn't it?
Yeah, it saves time on downstream tasks.
Yeah.
Once a feature hits shipped, the Sidekick gets a prompt to generate release notes from the approved spec and PR titles. It just eliminates that tedious manual step, and the integrations are mandatory here. JIRA for tickets, GitHub for PRs, Figma for the UI, and Confluence or Notion for policy documents. The information is all interconnected.
This all hinges on quality control, though. We talked about standardizing the flow, but that's useless if the inputs are garbage. You mentioned standard artifacts and their minimum bars.
Exactly. Systems beat silos only if the inputs meet a measurable bar of quality. If everyone follows the same structure and quality standard, the handoff risk just drops dramatically because the expectations are identical.
So walk us through that. What defines quality? What's the minimum bar for the research itself?
Okay, so look at the Research Digest minimum bar. It's very specific. Must have 3 or more independent sources, a clearly tagged insight, and a confidence level high, med, or low. Why 3 sources? To actively combat confirmation bias. If you only talk to one type of customer, you risk building for an anomaly. The system won't let you use low-confidence data to justify a high-cost feature.
That's a great forcing function, and the specification minimum bar seems even stricter. It forces accountability right into the requirements.
It is. A spec only meets the bar if it has the defined outcome, at least 5 acceptance criteria for testability, remember, a performance budget, and documented risks. If a spec is missing the outcome, it's instantly rejected. It eliminates the ability to ship a feature that is technically perfect, but strategically useless.
And then the ultimate quality check is the handoff packet minimum bar for delivery.
This is the checklist before hitting ready for tech review. It requires a signed spec, a linked prototype, a dependency list, and a high-level test plan. This is governance in action. It ensures engineering isn't pulling requirements from a prototype that was never validated.
Now let's talk about how the AI isn't just a drafting tool, but an active participant. The idea of sidekicks embedded in rituals seems to shift the AI from a one-off helper to an embedded institutional quality controller.
This changes the entire dynamic of key ceremonies. Let's take the daily stand-up. Usually it's status theater, people just listing what they did.
And the sidekick fixes that by forcing a resolution.
Precisely. The sidekick's input is all the open tickets and comments from the last 24 hours. Its required output is a summary of blockers and a proposed next action for each blocker, annotated with the owner and a due date. It transforms the meeting from "I'm blocked by Jane on X" to "next action, follow up with Jane Doe by 3 p.m. Tuesday."
That's a huge shift in accountability. Where else does this embedded AI shine?
In backlog grooming, it reduces the subjectivity that plagues prioritization. The sidekick clusters items by theme and suggests priority based on outcome, impact, and historical effort. It gives the team a data-driven starting point. In the spec review, the AI generates a review checklist from the acceptance criteria and flags ambiguous terms or missing data contracts. It's an instantaneous objective layer of QA.
This sounds transformative, but for anyone listening who's trying to sell this internally, the question is always, does it actually work? This is where the metrics that matter come in. If you're going to introduce this rigor, you have to prove the ROI.
You absolutely do. The system only scales if you can measure its efficacy. These metrics are tracked, ideally on a visible analytics frame right on the main board. The goal is to prove that the structured system reduces time and effort spent in the messy alignment and rework phases.
Let's start with the big one, the velocity metric. Time to alignment, or TTA.
So TTA is calculated as the date the first aligned spec is approved minus the date the discovery kickoff began. It measures how fast you move from identifying a problem to having a production-ready blueprint.
The sources claim an ambitious goal here, dropping TTA by 30 to 50% within just 2 sprints. That seems stunningly fast. How is that even feasible without sacrificing quality?
It's achieved by eliminating the internal debate over process. When the spec template is locked and the minimum bars are enforced, product managers spend zero time arguing about format. The focus shifts entirely to content and evidence. The structure itself removes like half of the administrative friction, and that enables the speed boost.
So TTA measures speed, but we need a metric for quality control, which brings us to the Spec Completeness Index, SCI.
Right. SCI directly tracks the adoption and rigor of the new process. It measures the percentage of specs that meet that full minimum bar we talked about. The target is high-quality documentation, 80% or greater SCI by sprint 3. If your SCI is low, the system is telling you teams are still taking dangerous shortcuts.
And the ultimate payoff of a high SCI should be a low rework rate.
Exactly. Rework rate is the brutal measure of handoff quality items reopened after review or test. The goal is strict, 10% or less. This is the financial metric. If you enforce high SCI, your rework rate drops, proving that investment in structure upstream pays off downstream.
Okay, moving on to implementation. Structure can breed fear, especially with data involved. What governance and guardrails are needed to maintain trust?
You have to make the structure unmissable and non-negotiable. First, consistency. Templates are branded and locked. Naming conventions are mandatory. For example, spec _team _feature _date. This eliminates canvas sprawl where every team creates their own version of the truth.
And the evidence policy for data integrity must be crystal clear, especially with AI involved.
Oh, it's crucial. The policy must clearly define approved sources, and teams must mark vendor claims as vendor provided. Furthermore, for teams in regulated environments, the system requires mandatory use of no PHI datasets, no personally identifiable information. This ensures the AI is only summarizing secure, anonymized data, protecting the organization from compliance risks.
That provides critical reassurance. So let's talk strategy. You can't implement this everywhere overnight. The sources detail a concise 4-week rollout for a pilot squad. How do you start?
The implementation roadmap is aggressive but targeted. Week 1 is foundation and baselining. You stand up the board, install the templates, connect Jira and Figma, and critically, you gather that week 0 number.
Baselining is the political move, right? You need to measure the pain before you introduce the cure.
Precisely. Without the baseline TTA and rework rate, you can't prove the ROI 2 months later. In week 2, you jump into rituals plus sidekicks. This is the enforcement phase. You embed the AI prompts into every ceremony and strictly enforce the minimum bars. This is where teams feel the initial friction, but it's essential.
And by week 4, you codify the process.
Yes, you lock the successful templates, publish the final conventions, and you open a lightweight template council, a small group that manages changes. This institutionalizes the change. It prevents ritual drift.
I appreciate that the guide also anticipated the resistance and anti-patterns that usually crop up.
Yeah, the anti-patterns are where teams try to find loopholes. Take unbounded AI prompts. If you let teams ask the AI anything, you risk unreliable output hallucinations. The fix is pragmatic. Provide a vetted prompt library and require a manual review gate for the AI output.
And the classic Canvas sprawl people creating 10 different boards instead of one.
Fixed by the mandatory naming conventions and the linking requirement. If a spec isn't properly linked to the branded discovery map, it can't proceed. The system is self-correcting.
This deep dive has shown us that the shortcut to scaling AI impact isn't more tools. It's enforcing a system where visibility, measurement, and alignment are non-negotiable. By focusing on TTA, SCI, and rework rate, the payoff is measurable speed and far less wasted effort.
Yeah, the core tension in scaling is always finding that balance between creative freedom, where those rapid local AI wins happen, and the necessary structure for repeatable enterprise governance. This guide really proves that governance through locked templates, naming conventions, and minimum bars is the engine of speed, not the brake.
So if repeatable alignment is the goal, you have to ask yourself, is your current workflow providing the governance needed to prevent ritual drift and specs without outcomes? Or are you just celebrating local, siloed AI wins that die at the handoff? Consider where your current information flow breaks down between discovery and delivery, and whether establishing a single visual operating system could finally close that gap.